The universe is vast. It's bigger than we can imagine. In every direction we see stars, galaxies and structures that stretch for billions of light years. Our own planet Earth is a tiny speck in this cosmic ocean. It's hard to grasp the sheer scale of it all. Just consider our sun. It's a star, a giant ball of hot gas that emits light and heat. Our sun seems huge to us. It's 109 times wider than Earth. But in the grand scheme of the universe, our sun is just an average-sized star. There are stars out there that dwarf our sun in comparison. These stellar giants are called supergiant stars. They can be hundreds of times larger than our sun. Some supergiants are even thousands of times larger. If a supergiant replaced our sun, it would engulf the orbits of Mercury, Venus, Earth, and even Mars. The vastness of the universe doesn't stop at stars, though. Stars are grouped together in massive collections called galaxies. Our own galaxy, the Milky Way, contains billions of stars, and the Milky Way is just one of billions of galaxies in the observable universe. Stars come in different sizes and temperatures. Our sun is a yellow dwarf star, a relatively common type of star, but some stars are true giants. Supergiant stars are much larger and more massive than our sun. They burn brighter, but have shorter lifespans. One famous example is Betelgeuse, a red supergiant in the constellation Orion. Betelgeuse is so large that if it replaced our sun, its surface would extend beyond Jupiter's orbit. Another type of giant star is the blue supergiant. These stars are even hotter and brighter than red supergiants. They live fast and die young, often ending their lives in spectacular supernova explosions. The existence of supergiant stars highlights the vast range of scales in the universe. Our sun might seem impressive, but it's dwarfed by these cosmic titans. And as we'll see, even supergiant stars are tiny compared to the larger structures in the universe. Galaxies are vast collections of stars, gas, dust, and dark matter held together by gravity. They come in various shapes and sizes, from spiral galaxies like our own Milky Way, to elliptical galaxies and irregular galaxies. Our Milky Way is a barred spiral galaxy, about 100,000 light-years across. It contains billions of stars, including our sun, which resides in one of the Milky Way's spiral arms. But the Milky Way is just one galaxy among billions. Some galaxies are even larger and more massive than our own. For example, IC 1101 is a supergiant elliptical galaxy located about 1 billion light-years away from Earth. IC 1101 is estimated to be about 6 million light-years across, making it one of the largest known galaxies in the observable universe. It dwarfs the Milky Way in size and contains trillions of stars. The Milky Way, our home galaxy, is a vast and complex structure. It's a barred spiral galaxy, meaning it has a central bar-shaped structure from which spiral arms extend. Our solar system is located about 27,000 light-years from the galactic center in a relatively quiet spiral arm called the Orion arm. The Milky Way is constantly rotating, with stars and gas orbiting the galactic center. It takes our solar system about 230 million years to complete one orbit around the Milky Way. While the Milky Way is vast, it's just one galaxy among billions in the observable universe. Through telescopes, we can observe distant galaxies of various shapes and sizes, each containing billions or even trillions of stars. These galaxies are not randomly scattered throughout space. They are often found in groups or clusters, held together by their mutual gravitational attraction. These galaxy clusters are some of the largest structures in the universe. Section 5. Galactic Clusters, Gravity's Pull. Galaxies are not isolated islands in space. Gravity draws them together into larger structures called galaxy clusters. These clusters can contain hundreds or even thousands of galaxies, all bound together by their mutual gravitational attraction. The galaxies within a cluster are not stationary. They move around within the cluster, their paths influenced by the gravity of all the other galaxies in the cluster. Sometimes galaxies collide and merge, creating even larger galaxies in the process. One well-known galaxy cluster is the Virgo cluster, located about 50 million light-years away from Earth. The Virgo cluster contains over 1,000 galaxies and is the closest major galaxy cluster to our own local group. Galaxy clusters are not the largest structures in the universe, however. They themselves are grouped together into even larger structures called superclusters. Section 6. Superclusters, Laniakea and Beyond. Galaxy clusters are not randomly scattered throughout the universe either. They are organized into even larger structures called superclusters. Superclusters are vast filaments and sheets of galaxies, clusters, and groups, all interconnected by gravity. Our own Milky Way galaxy is part of a supercluster called Laniakea. Laniakea is about 520 million light-years across and contains an estimated 100,000 galaxies, including our local group and the Virgo cluster. The name Laniakea comes from the Hawaiian words for immeasurable heaven. It was chosen to honor Polynesian navigators who used their knowledge of the stars to navigate the Pacific Ocean. Superclusters like Laniakea are some of the largest structures in the known universe, but even these colossal structures are not evenly distributed throughout space. Between them lie vast regions of emptiness known as cosmic voids. Section 7. Vast voids, emptiness in space. While superclusters represent regions of high galaxy density, the universe also contains vast regions of relative emptiness known as cosmic voids. These voids are not completely empty, but they contain far fewer galaxies than the filaments and sheets of superclusters. Cosmic voids can be hundreds of millions of light-years across. One example is the Bootes void, located about 700 million light-years away from Earth. The Bootes void is estimated to be about 330 million light-years across, making it one of the largest known voids in the universe. The existence of cosmic voids is thought to be a result of the way the universe evolved after the Big Bang. Tiny fluctuations in the early universe led to regions of slightly higher or lower density. Over time, gravity amplified these differences, pulling matter together to form galaxies and clusters in some regions while leaving other regions relatively empty. These empty regions became the cosmic voids we observe today. Section 8. Great Walls, the Sloan Great Wall. While cosmic voids represent the vast emptiness of space, other structures highlight the immense scale of the universe's structure. Among these are the Great Walls, immense filaments of galaxies that stretch for billions of light-years. One such structure is the Sloan Great Wall, discovered in 2003 by astronomers analyzing data from the Sloan Digital Sky Survey. The Sloan Great Wall is a massive filament of galaxies that stretches for about 1.4 billion light-years, making it one of the largest known structures in the universe. This cosmic wall is so vast that it's difficult to comprehend its size. If we could shrink the Milky Way down to the size of a grain of sand, the Sloan Great Wall would be like a string of sand grains stretching across a football field. The Sloan Great Wall is not the only such structure in the universe. Another example is the Hercules-Corona Borealis Great Wall, which is even larger than the Sloan Great Wall. Section 9. Hercules-Corona Borealis Great Wall. The Hercules-Corona Borealis Great Wall, discovered in 2013, is another example of the immense structures that make up the cosmic web. This colossal filament of galaxies stretches for an estimated 10 billion light-years, making it the largest known structure in the observable universe. To put its size into perspective, the observable universe itself is about 93 billion light-years in diameter. So the Hercules-Corona Borealis Great Wall spans roughly 10% of the observable universe. Like other Great Walls, the Hercules-Corona Borealis Great Wall is thought to have formed due to the gravitational collapse of matter along vast filaments of the cosmic web. These filaments channel gas and galaxies into dense regions, creating the walls and clusters we observe today. The discovery of such enormous structures challenges our understanding of the universe's large-scale structure and raises questions about the processes that drive the formation of such colossal objects. Section 10. The Cosmic Web, a universe interconnected. As we've explored, the universe is not a random scattering of stars and galaxies, it's a highly structured and interconnected web of filaments, sheets, voids, and clusters, all shaped by the relentless pull of gravity. This cosmic web is thought to have originated from tiny density fluctuations in the early universe. Over billions of years, gravity amplified these fluctuations, drawing matter together to form galaxies, clusters, and superclusters along vast filaments of dark matter. The cosmic web is constantly evolving. Galaxies move along the filaments, sometimes colliding and merging to form larger galaxies. Voids continue to expand as matter drains away from them, and new structures form as gravity pulls matter together. Understanding the cosmic web is crucial for comprehending the universe's large-scale structure and evolution. By studying the distribution of galaxies and clusters, astronomers can map the cosmic web and learn about the processes that shaped the universe we see today. Section 11. Conclusion. Our place in the cosmos. From the smallest stars to the largest superclusters, the universe is a place of incredible scale and diversity. As we explore the cosmos and uncover its secrets, we gain a deeper appreciation for our own place within this vast and awe-inspiring expanse. Our planet Earth is a tiny speck in the grand scheme of things, but it's also a unique and precious world, teeming with life and full of wonder. As we continue to explore the universe and push the boundaries of our knowledge, we should never forget the importance of protecting and preserving our own cosmic home.